Okay. 11.8 is about expected value. All right. So expected value is sort of one way of thinking about like the average. If you were to repeat a specific thing a lot of times, what would be the average outcome is basically what it's looking at. All right, so number one, a $20 bill, two $10 bills, three $5 bills, and four $1 bills are placed in a bag. If a bill is chosen at random, what is the expected value for the amount chosen? So basically, if you were to repeat this, a million times or whatever, what would be the average outcome you would get? And so we're going to solve these problems using a table. All right. So the first column is going to be X, and that's going to list all of the possible outcomes. So the possible outcomes in this case, you could get a 20, a 10, a 5, or a 1. Those are the possible outcomes. And then the next column is going to be the probability of each of those outcomes. All right, so to know the probability, let's count up how many bills are in the bag. So basically 1 plus 2 plus 3 plus 4. So that's going to equal 10. So there's a total of 10 bills inside the bag. And so there's one $20 bill. So the probability of getting the $20 bill is 1 out of 10. And there's two $10 bills. So the probability of getting a $10 bill is 2 out of 10. And there's three $5 bills. So the probability of drawing one of those is 3 out of 10. And the probability of getting a $1 bill is 4 out of 10. All right. And you could reduce those and you could write it as a decimal or whatever. It doesn't really matter at this point because that's not our final answer yet. But when you make this table, this is basically what they call a probability distribution. And if you were to add up all the probabilities, it would equal 1. Okay, so then we're going to multiply across each row of the table. So we're going to multiply X times the probability of X. Calculator. I don't know. Calculator. Oh, it's up here. Oh, thank you. All right. Okay, so we can just do 20 times 1 divided by 10. You don't have to. No, you can just put it right in there. All right, that's 2. All right, so we're just multiplying. So you could put it in parentheses, but you don't actually have to. That's 2. And then 10 times 2 divided by 10 equals 2 as well. And then 5 times 3 divided by 10 is 1.5. And then 1 times 4 divided by 10 is 0.4. All right, and then we're going to add this last column right here. So 2 plus 2 plus 1.5 plus 0.4 equals 5.9. All right, and that is your answer. $5.90. So if you repeated this same experiment or the same game a whole bunch of times, the average amount you would be getting is $5.90 on average. All right, number 2. In a game, you flip a coin twice and record the number of heads that occur. You get 10 points for 2 heads, 0 points for 1 head, and 5 points for no heads. What is the expected value for the number of points you'll win per turn? All right. So let's do a table. So in this case, they want to know what is the expected value for the number of points. So the column for X is going to be, whoops, column for X is going to be points. All right. All right. So let me make a column for the number of heads, because that's what the points are based off of. So you could get 2 heads, 1 head, or no heads. And then for 2 heads, you get 10 points. For 1 head, you get 0 points. And for no heads, you get 5 points. Then we need to do a column for the probability of those. Okay. So if you flip a coin twice, the possible outcomes you could have would be heads and then heads, heads and then tails, tails and then heads, or tails and then tails. So there's 4 possible outcomes you could have when you flip a coin 2 times. So out of those 4 outcomes, only one of them has 2 heads. So the probability of getting 2 heads is 1 out of 4. There's 2 options that have exactly 1 head. So the probability of getting 1 head is 2 out of 4. And there's 1 option that has no heads. So the probability of getting no heads is 1 out of 4. And you can see if you add up the probability column, it'll equal to 1. 1/4 plus 2/4 plus 1/4 equals to 1. So that's always going to be the case if you do it correctly. So then X multiplied by the probability of X. Yeah. Yeah, because what they're asking about was just what's the expected value of number of points. So that's what we're doing, just the number of points column times the probability. So 10 times 1 divided by 4 is 2.5. 0 times anything is going to be 0. And then 5 times 1 divided by 4 equals 1.25. And then we're just going to add up that column. So 2.5 plus 1.25 equals 3.75. And that's the answer, 3.75 points.
How did you do the top one? What did you like? 2 times 10 divided by
10 times 1 divided by 4. You're not using the first column. All right. Number 3 says there's an equally likely chance that a falling dart will land anywhere on the rug below. The following system is used to find the number of points the player wins. What is the expected value for the number of points won? All right. So we can make a column for the color since that's what the number of points is based on. And then they're wanting the expected value of the number of points. So the X column would be for number of points. So black is 40 points, gray 20 points, white 0 points. And then a column for the probability. So you have this rug. So there's 1, 2, 3, 4, 5 times 3. So there's 15 sections, like little squares on that rug. And 6 of them are black. So the probability would be 6 out of 15 for black. And then 6 gray ones. So that's also 6 out of 15. And there's 3 white ones. So that's 3 out of 15. And then we'll just multiply X times the probability of X. So, because just counting how many black rectangles are there. So there's 6 black ones and there's 6 gray ones and there's 3 white ones. So like so basically what they're saying is like you're standing, maybe up on a balcony and there's this rug at the bottom and you're dropping a dart onto it. And so when you drop that dart, what's the probability that it lands on black is 6 out of 15. So 40 times 6 divided by 15 is 16. And 20 times 6 divided by 15 equals 8. And then 0 times anything is 0. And then I'm going to add up this column, and that's going to be the answer. So 16 plus 8 is 24. So if you play this game a lot of times, you get on an average of 24 points per time that you play it.
Are we just doing 11.8 today?
Yes. All right, number 4, a mysterious card playing squirrel offers you the opportunity to join his game. The rules are to play, you must pay him $2. If you pick a spade from a shuffled pack, you win $9. Find the expected value you win or lose per game. All right. So let's see. All right, so you could win by getting a spade, or you could lose by not getting a spade. So they want to know, so we're looking for the expected value of the amount of money. So X is the amount of money you win or lose. So either way, whether you win or lose, you start off by paying $2. So you're going to start off with -2. And then if you win, he gives you $9. If you lose, then you're just out the $2. So we can go ahead and say that that equals a +7. All right, and then the probability of each of those things happening. So you're just drawing one card out of a deck. So the probability that it's going to be a spade is 1/4. And the probability it's not going to be a spade then is 3/4. Or I could have said 13 out of 52 and 39 out of 52. Either way, it doesn't matter. So then I'm going to multiply the X times the probability of X. So 7 times 1 divided by 4 is 1.75. And -2 times 3 divided by 4 is -1.5. So then I'm going to add up that column, and that's going to be 25 cents. So that's positive 25 cents. So you're winning an average of 25 cents per time of playing the game, which means that stupid squirrel is going to eventually run out of money. All right, number 5 says a dice game involves rolling 2 dice. If you roll a 2, 3, 4, 10, 11, or 12, you win $5. If you roll a 5, 6, 7, 8, or 9, you lose $5. Find the expected value you win or lose per game. All right. So if you win or lose, I'll just win or lose at that. So if you win, that's positive $5. If you lose, that's negative $5. So what's the probability of winning? So in order to win, you need to roll one of these. And by that, they mean the sum of the 2 dice equals one of those things. So 2, 3, 4 would be those. And then 10, 11, 12 would be those. So that's 6 and 6, so that's 12 out of 36. So then the probability for losing would be all the rest of those, which would be 24 out of 36. Or you could reduce it to 1/3 and 2/3, either way, doesn't matter. Then we're going to multiply x times the probability of x. So 5 times 12 divided by 36. All right, so I'll go ahead and round it to the nearest cent. So that's 1.67. And -5 times 24 divided by 36 equals -3.33. And then I'll just add that column together. So that would be -1.66. So that means on average, you lose $1.66. Okay, so on average, you're losing $1.66 per time that you play the game. All right. Number 6 says a term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics Report, the probability of the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company. All right, so there are two possible outcomes. Either the policyholder lives throughout the year or she dies. Okay. And so the value of that to the insurance company is what we're looking for. So either way, she's going to start out by paying them $530. So they're going to start out by receiving $530 either way. All right, and then if she dies, then they have to pay $250,000, and if otherwise they don't. So then the probability. So it says the probability that she will survive the year is, so in other words, the probability that she doesn't die is 0.99791. So that means the probability that she will die is 1 minus 0.99791, because like I told you, the probabilities have to add up to 1. All right, so probability that she lives is that, the probability she doesn't live is 1 minus it. So then we're just going to do X times the probability of X. So we can just multiply this times that, and this times that. So like on the second line, we can just, we can just put it into the calculator like that, as long as we do put parentheses around everything. So we don't necessarily have to subtract like beforehand. We can just put it all in like that. And I guess I can go ahead and round it to the nearest cent.
What is that X stand for?
X is the value to the insurance company. So it's how much money the insurance company either profits or loses. Okay, so I got 528.89 and I got negative 521.39. So then I'm just going to add that column up. So it's going to give me $7.50. All right, so that means that if this insurance company were to sell a whole bunch of insurance policies, just like this one, then they would profit an average of $7.50 per policy in earnings. All right, number 7, a construction company is planning to bid on a building contract. The bid costs the company $5,000. The probability the bid is accepted is 1/4. If the bid is accepted, the company will make $20,000 minus the cost of the bid. Find the expected value in this situation and describe what it means. All right. So do the table. All right, so when you make the table, make sure that you list all the possible outcomes, which there will be at least 2 and sometimes more possible outcomes. So in this case, the possible outcomes is either the bid is accepted or it's not. So we could call that not accepted, or we can call that rejected. Either way, same thing. All right, so we're looking for the expected value of how much money they're either going to profit or lose. So X is the amount of money. So when they're putting this bid together, it costs them $5,000 to do so. And it will cost them that whether their bid is accepted or not. So I'll start out with negative 5,000. All right, and if their bid is accepted, so that means they get the job that they're bidding on, then they're going to be paid $20,000. So if their bid is accepted, they're going to make 20,000. So we add 20,000 to that. And then it tells us directly that the probability the bid is accepted is 1/4. So what is the probability that the bid is not accepted? 3/4. Because you just, 1 minus 1/4 is 3/4. Then we would multiply X times the probability of X. So just put in parentheses, -5,000 plus 20,000 times 1 divided by 4 is 3,750. And then -5,000 times 3 divided by 4 is -3,750. So if we add up that column, it equals to 0. So their expected value is 0. So that means if they were to do a lot of bids like this, their average profit would be $0. So they're just breaking even. So that's not a great business model, but at least they're not losing money. Not making any either. All right, number 8, suppose that a raffle ticket costs $20. One ticket will be drawn for a grand prize of $10,000, and 2 tickets will be drawn for a second prize of $500 each. If you buy 1 ticket out of the 250 tickets sold, what is your expected value and what does that mean? All right, so you buy 1 raffle ticket. And so let's list the possible outcomes. So the possible outcomes, you could win the grand prize, you could win the second prize, or you could win nothing. Okay, those are the possible outcomes when you buy a ticket, right? So let's look at the value of each of those outcomes for you. My computer's just being kind of really slow today. Laggy. All right, so no matter what the outcome is, you have started out by buying the ticket, which cost you $20. So each one is going to start out with -20. And then if you win the grand prize, you're going to receive $10,000. So add 10,000 to that. And then if you win the second prize, you're going to win $500. So add 500 to that. And if you have no prize, then nothing. All right. All right, and so then let's look at the probability of each of those. So if you've purchased one ticket, the probability of getting the one grand prize out of those 250 tickets sold is 1 out of 250. And then 2 tickets are going to get the second prize. So the probability of that is 2 out of 250. And then what's the probability of no prize? 247 out of 250. All right, because they're going to draw 1 ticket that's going to get the grand prize, and they're going to draw 2 tickets that's going to get the second prize, and then 247 of those tickets get nothing. All right. So then we're going to do X times the probability of X. So I'm just going to put in parentheses, -20 plus 10,000, close the parentheses, multiply by 1 divided by 250. So that's 39.92. And then -20 in parentheses plus 500. Multiplied by 2 divided by 250 equals 384. And then -20 times 247 divided by 250 is -1976. And then we're just going to add up that column to get the final answer. And that equals $24. So the average winnings per ticket is $24. So that's bad for who's ever running this raffle, because that means they're losing $24 per ticket. All right, that's the end of 11.8. So I'll send out an email later saying which one do you prefer of having the test before or after Thanksgiving, and then you can just respond back to that email to let me know if you have a preference. All righty, that's it. Huh? I don't know yet. That's what I was just saying. It's either gonna be right before Thanksgiving or right after Thanksgiving. And I'm gonna send an email to ask everybody, what do you prefer? So just respond back to that email and let me know what you prefer. And then I'll just go with whatever the majority of people say.